The universe opens like a silent ocean, endless, black, without horizon. Across its surface, points of light gleam, stars, galaxies, nebulae, fragile lanterns adrift in infinite night. They shine with certainty, yet beneath them stretches a question deeper than darkness itself. What holds them there? What invisible scaffold suspends these lights across the void? Imagine a lighthouse rising above an endless sea. Its beam sweeps across the waters, steady, guiding, eternal. But unlike stone towers rooted in earth, this one stands on nothing. It rises from emptiness, anchored to an absence. Its light is real, but its foundation is unseen. This is the paradox of the cosmos. Galaxies spin faster than they should, clusters hold together against all odds. Light bends where no matter can be found. Something is there, a hidden architecture, silent but immense. It is called dark matter, a name less of knowledge than of ignorance. It neither glows nor absorbs, neither burns nor reflects. It leaves no trace but its gravity, the quiet pull that sculpts the universe. And so the stars, we know the suns, the planets, the atoms of life itself, are mere ornaments upon a far greater structure, a visible cosmos draped over an invisible frame. If most of existence is unseen, then what is reality? Is it the lighthouse we behold, or the nothing upon which it stands? The opening question remains, suspended like a lantern in the dark. Is the foundation of the universe a substance beyond imagination, or is the lighthouse truly built on nothing at all? The story of dark matter begins long before the name was ever spoken, long before science had instruments to glimpse the hidden. It begins with eyes raised to the sky. For millennia, humanity watched the motions of the heavens. Ancient astronomers in Mesopotamia tracked the paths of planets, measuring their wanderings against the steady backdrop of stars. The Greeks, with their philosophy of spheres and harmony, imagined crystalline shells encasing the cosmos, turning in perfect balance. Aristotle believed each object had its natural place. Stones fell to earth, flames rose to the sky, and the heavens themselves moved in circles by divine necessity. For him, the visible explained itself. There was no need to search for what could not be seen. Centuries later, Galileo dropped spheres from towers and rolled them across inclined planes. His experiments whispered a dangerous idea. Motion was universal. What governed a falling stone also governed the moon. And then came Newton. In the 17th century, he took Galileo's insight and stretched it to the cosmos itself. His law of universal gravitation declared that every mass pulled on every other. The apple falling to earth was tethered by the same invisible thread that bound the moon to its orbit. For Newton, the cosmos was predictable, mechanical, a clockwork turning in silence. And in this grand design, every motion could be explained by visible matter and its universal pull. But history has always been kindest to those who ask the next question. In the 19th century, astronomers discovered Neptune not by seeing it, but by feeling its pull. Uranus moved strangely across the sky, its orbit tugged by something unseen. Mathematicians calculated the mass and position of a hidden planet, and telescopes soon confirmed it. The lesson was powerful. Unseen mass could be found by the motions it caused, and for a time this was enough. The cosmos was still a place of stars, gas, and dust, no hidden realms, only undiscovered worlds. That belief fractured in 1933. A Swiss astronomer named Fritz Zwicky turned his telescope to the Coma cluster a vast collection of galaxies bound in a cosmic swarm. By applying Newton's laws, he expected the galaxies' motion to match the pull of their combined visible mass, the stars, the gas, the dust. Instead, he found chaos. The galaxies were moving too fast, flying on trajectories that should have torn the cluster apart, and yet they held together. Zwicky's conclusion was both simple and shocking. There must be unseen mass, vastly more than the light revealed. He named it dunkel materie, dark matter. Few believed him. For decades, Zwicky's claim remained a curiosity, an outlier in the steady progress of astronomy. But then, in the 1970s, Vera Rubin looked deeper. She studied the rotation curves of spiral galaxies, majestic disks of stars turning like cosmic whirlpools. According to Newtonian gravity, stars near the center should move swiftly, while those at the edges, far from most of the mass, should drift more slowly. It was the same way planets move around the sun, Mercury quick, Neptune slow. But Rubin found something different. Stars at the edges of galaxies were moving just as fast as those near the center, defying expectations. The galaxies should have flung their outer stars into the void. Instead, they held tight. Something invisible was binding them. Rubin's data was undeniable. What Zwicky had glimpsed in clusters, she confirmed in galaxies. The cosmos was scaffolded by something unseen. Through the last decades of the 20th century, more signs accumulated. Gravitational lensing, Einstein's general relativity made visible revealed, light bending around invisible masses. Whole clusters of galaxies acted as magnifying glasses, distorting the light of objects behind them. Sometimes the light curved where no visible matter lay at all. Again, the invisible announced itself through its pull. On the grandest scales, the cosmic microwave background became the deepest clue. This relic radiation, discovered by Penzias and Wilson in 1965, was later mapped in exquisite detail by satellites like COBE, WMAP, and Planck. The faint ripples in its glow told a story of matter density in the infant universe. From those ripples, cosmologists calculated the balance of ingredients. The result was staggering. Only about 5% of the universe was ordinary matter. The atoms of stars, planets, and life. Roughly 27% was dark matter. The rest, something stranger still, dark energy. By the dawn of the 21st century, the revelation was unavoidable. The visible universe, the stars that inspired myths, the galaxies revealed by telescopes, the planets that carried life, was only a sliver. The true cosmos was dominated by a shadow, and so the metaphor of the lighthouse emerges. The stars are its beams, steady and real. The galaxies are its lanterns, spiraling in brilliance. But the foundation upon which they rest, the invisible structure that holds them, is unseen. It is a tower built on nothing, and yet it guides the entire cosmos. But here lies the unsettling truth. While humanity discovered its presence, its nature remained hidden. Dark matter could not be touched or tasted, could not be caught in a beam of light. Unlike Neptune, it would never be seen through a telescope. Unlike ordinary matter, it would never burn or shine. Its existence was inferred, not witnessed, and so the stage was set for the great puzzle of modern cosmology. How do you study what will not reveal itself? The discovery of dark matter was not one moment, but many. A Swiss astronomer peering at galaxies that moved too fast. A woman measuring the rotation of spirals across the night. Satellites mapping ancient light. Lenses bending beams from invisible hands. Each revelation pointed in the same direction. The universe humanity thought it knew was only a shadow. The real cosmos lay beneath, silent, invisible, but vast. And with that discovery came a deeper, more haunting realization. If everything seen rests on something unseen, then reality itself is not what it seems. The lighthouse of the cosmos shines across the sea of time, but its foundations vanish into the dark. Gravity, light, and matter, the three pillars of cosmic understanding. For centuries, they were thought sufficient to explain the heavens. Yet, as telescopes sharpened and measurements grew precise, a rupture appeared in the fabric of certainty. The stars themselves whispered of a hidden truth. The universe was not what it seemed. The first contradiction emerged, not from absence, but from motion. In spiral galaxies, stars on the outskirts orbit as though tethered by an invisible hand. By Newton's laws, their speeds should diminish with distance from the galactic core, falling off like planets receding from a sun. Instead, they whirl. With astonishing uniformity, their velocities flat across vast spans of starlight. If only visible matter accounted for their gravity, these galaxies should have torn apart long ago. Yet they hold together, bound by something unseen. The paradox deepened with clusters of galaxies. Fritz Zwicky's calculations in 1933 had already exposed a deficit. Galaxies in the Coma cluster sped as though immersed in a hidden ocean of mass. Later, gravitational lensing revealed that light itself curved around invisible structures, arcs and rings traced by galaxies that were not there. Reality was distorted, not by what was seen, but by what was missing. Here lay the shock. The cosmos was not ruled by the familiar atoms of stars, planets, and human bodies. Baryonic matter, the kind that shines and forms life, composes a mere fraction of existence, roughly 5%. The rest, over a quarter of the universe's total content, is dark matter, unseen, untouchable, undetected. Its contradiction lies in its silence. Electromagnetism shapes chemistry, yet dark matter responds to no such force. The strong and weak nuclear interactions bind particles, but dark matter drifts beyond their grasp. It reveals itself only through gravity, pulling galaxies into spirals, sculpting the cosmic web, yet never emitting, absorbing, or reflecting light. A paradox of weakness and dominance emerges. In the quantum world, dark matter appears powerless, invisible to every particle interaction known. Yet, on the largest scales of the cosmos, it dictates everything. It is the architect of galaxies, the mason of filaments stretching hundreds of millions of light years, the skeleton of the universe. This realization cut deep into the philosophy of science. For millennia, human thought equated the real with the visible. To see was to know. But here was a substance shaping the entire cosmos, forever beyond sight. The revelation suggested that the universe humans experience with its stars, nebulae, and radiant galaxies is but a shadow world, resting upon a deeper, invisible reality. The emotional weight of this shock cannot be understated. It is not simply that dark matter remains unseen. It is that existence itself depends on it. Without it, galaxies would unravel, stars would scatter, and planets would drift into darkness. Without it, the very fabric of cosmic history would collapse. Humanity lives within a lighthouse, its beams sweeping across the sea of night, but the tower beneath is missing, invisible, built on nothing that can be touched. The rupture extends further. If dark matter is real, it lies outside the standard. Model of particle physics, the most successful scientific framework ever built. Every particle within it has been catalogued, confirmed, and measured, from electrons to quarks to neutrinos. Yet none can account for this missing mass. Dark matter resists incorporation, mocking the symmetry of known physics. It is the guest that refuses to appear at the banquet of particles. This is why its existence terrifies theorists as much as it excites them. For if dark matter is matter, then an entire shadow realm of physics exists, parallel to the visible. 1. If it is not matter at all, then gravity itself may be incomplete, requiring revision of Einstein's masterpiece. Both possibilities shatter the illusion of comprehension. Thus, the shock of dark matter is twofold. First, that the universe humanity thought it knew is built mostly from what cannot be seen. Second, that science, for all its power, cannot yet decide what this invisible foundation truly is. The stars continue their silent whirl, obeying laws that hint at something beyond sight. The galaxies cluster, filament, and bend light into arcs around emptiness. The cosmos stands as proof that something vast and invisible binds it all. And yet, in the silence of that truth lies an unease. Reality itself is scaffolded upon absence. The lighthouse shines, but its stones are nowhere to be found. The shock of dark matter's invisibility did not still the pursuit. Instead, it ignited an era of relentless investigation. If the cosmos was scaffolded by shadows, then science would chase the traces of its unseen architecture, however faint, however elusive. The first frontier lay in the galaxies themselves. Vera Rubin's observations of flat rotation curves were not anomalies to be explained away. They were signatures of a deeper law. Astronomers mapped hundreds of spiral galaxies, each showing the same defiance of Newtonian expectation. The outskirts of galaxies spun too quickly, as though immersed in a vast halo of hidden mass. Theorists began to sketch models, galaxies not as islands of stars, but as lanterns hung in invisible cocoons, each surrounded by a dark sphere more massive than the luminous core within. Evidence grew not only in individual galaxies, but across clusters. In 2006, a cosmic collision provided a striking clue: the Bullet Cluster. Two galaxy clusters had passed through each other, their visible matter hot, X-ray glowing gas colliding and slowing down, while the unseen mass surged, ahead unimpeded. Gravitational lensing maps revealed that most of the gravitational influence was not where the gas was, but where nothing seemed to be. The Bullet Cluster became a natural experiment in the cosmos, proof that dark matter behaved as if it were a substance distinct from visible matter, refusing to interact except through gravity to penetrate deeper. Cosmologists turned to the earliest light of the universe, the cosmic microwave background. Satellites like COBE, WMAP, and Planck traced the faint ripples of radiation left from 380,000 years after the Big Bang. In those patterns lay clues to the density of matter, normal and dark. The data spoke with precision. Only about 5% of the universe is ordinary matter. 27% is dark matter. The rest, a more haunting mystery still, is dark energy. The CMB revealed that dark matter was not an afterthought but an essential ingredient, present from the beginning, guiding the first atoms into the seeds of stars. But what is it? To answer, physicists sought particles beyond the standard model. One hypothesis envisioned WIMPs, weakly interacting massive particles, heavy, invisible, but sensitive to gravity and perhaps to the weak nuclear force. Laboratories were carved deep beneath mountains, shielded from cosmic rays, filled with tanks of xenon or argon chilled to silence. The hope, a rare collision between a passing dark matter particle and an atomic nucleus. Decades of experiments, CDMs, xenon, lux, pandex, strained toward the faintest glimmer of interaction. To date, the silence continues. If WIMPs remain hidden, another candidate lingers at the opposite extreme. The axion, born from theoretical attempts to resolve puzzles in quantum chromodynamics. Ixions would be light, ghost-like particles, slipping through detectors almost unnoticed. Instruments like a DMX, and cast listen for their subtle whispers, searching for their transformation into photons in strong magnetic fields. Still others look to neutrinos, ghostly particles already known for their near invisibility. A hypothetical, sterile neutrino, even less interactive than the three familiar kinds, could fill the dark matter role. In each case, the candidates point to physics beyond the established framework, suggesting an unseen sector of reality. Yet dark matter might not be a particle at all. Alternative theories propose that gravity itself changes over vast distances, or weak accelerations. Modified Newtonian dynamics, Mond attempts to explain galactic motions without invoking unseen matter. More sophisticated descendants, such as Teves, extend Einstein's relativity to new regimes. But though these models succeed in galaxies, they stumble in clusters and fail against the bullet cluster's testimony. The weight of evidence still leans toward matter unseen. Meanwhile, supercomputers offered visions of the cosmos in the language of mathematics. Simulations like the Millennium and Illustrious projects modeled billions of particles of dark matter, tracing their gravitational interactions across cosmic time. The results were staggering. A universe of filaments and voids where galaxies formed. Along the spines of an invisible web, this cosmic web matched the large-scale distribution of galaxies observed in surveys. A cartography of matter, both seen and unseen. In this picture, dark matter is the architect, laying down the scaffold on which stars and galaxies can ignite. Radio astronomy opened another path. Hydrogen, the most abundant element, emits a faint 21 centimeter signal. By tracing this emission across cosmic time, astronomers hope to map the influence of dark matter in the earliest epochs. Instruments like LOFA and the upcoming Square Kilometre Array aim to chart hydrogen's history during the cosmic dark ages, revealing how dark matter shaped the first stars. Even within our own galaxy, astronomers search for relics of the first enrichment. Some stars, ancient and metal-poor, may carry chemical fingerprints of population 3 stars, the first generation born in dark matter halos. Their compositions hint at explosions seeded in scaffolds, invisible yet indispensable, but anomalies persist. Small galaxies sometimes defy predictions, showing too few satellites or too dense cores compared to simulations. Perhaps dark matter interacts with itself in subtle ways. Perhaps its properties are stranger than imagined. Or perhaps the laws of gravity still conceal surprises. Thus, the investigation does not merely deepen, it splinters into possibilities. Each path, WIMPs, axions, steadily, neutrinos, modified gravity, self-interacting dark matter promises. Resolution but so far yields only silence. The universe itself continues to serve as the laboratory. Arcs of light bend around invisible masses. Stars whirl in defiance of expectation. Clusters collide and reveal separations of matter and mass. The cosmic microwave background preserves the faint whisper of the invisible scaffold. And yet, for all this evidence, the substance itself remains hidden. The deeper humanity looks, the more profound the mystery becomes. Dark matter is at once the most certain and most elusive of truths. Without it, the universe unravels. With it, reality rests upon something unseen, untouchable, perhaps unknowable. The deeper astronomers and physicists pressed into the shadows, the more the mystery of dark matter widened. What first appeared as a silent correction to gravity, a hidden scaffolding to steady galaxies, began to unfold as something more profound, a force shaping the very destiny of the cosmos, yet still refusing to reveal its face. On the grandest scales, galaxies are not strewn randomly like dust scattered by the wind. Instead, they are woven into a tapestry, filaments stretching for hundreds of millions of light years, intersecting at luminous knots where clusters reside. Between them, yawning voids extend like oceans of emptiness. This is the cosmic web, traced not by starlight but by dark matter's invisible gravity. Supercomputers show how, over billions of years, this web spun itself from the earliest quantum ripples, providing channels along which galaxies formed. Yet the more accurate the models became, the more unsettling their implications. Without dark matter, the universe would never have sculpted such structure. But the models also revealed gaps, mismatches, anomalies, faint but persistent hints that even this invisible substance was not the full story. Then came the supermassive black holes, discovered in galaxies that existed only a few 100 million years after the Big Bang. According to current theories, there should not have been enough time for such giants to form. Gravity, guided by dark matter, should have built galaxies slowly. Yet these monsters appeared early, burning as quasars in the young universe, suggesting that dark matter might accelerate growth in ways not yet understood. Was dark matter clumping more efficiently than models predicted, or was another, deeper mechanism at play? As evidence mounted, tensions emerged in the very constants of cosmology. Measurements of the Hubble constant, the rate of expansion of the universe diverged depending on the method used. Observations of the cosmic microwave background by the Planck satellite implied one value. Measurements of supernova and galaxies in the local universe gave another. The discrepancy refused to vanish with improved data, instead sharpening like a fracture in theory. Some scientists began to suspect that unknown physics was hidden in the gap, and dark matter was a prime suspect. Perhaps its properties evolved over cosmic time. Perhaps it interacted faintly with dark energy, the other great shadow of the cosmos. This possibility opened doors into speculation of a dark sector, an entire hidden realm of particles and forces interacting among themselves, almost entirely detached from ordinary matter. If such a sector exists, then what humans perceive as dark matter may be only a fraction of its richness, a faint gravitational echo of a parallel physics. Just as visible matter builds atoms, molecules, and stars, so too could the dark sector build complex structures invisible to human senses. Galaxies of shadow, bound by forces alien to known physics, might drift alongside the luminous cosmos, unseen and undetectable except for their gravitational pull. The lighthouse may not be built on nothing, but on an entire foundation of hidden architecture. Yet alternative visions rose in defiance. Could it be that dark matter does not exist at all, that gravity itself bends differently at cosmic scales? Modified Newtonian dynamics, though challenged by the bullet cluster, still lingers in the margins. Some propose that general relativity, Einstein's most celebrated achievement, may yet be incomplete. If so, then the stars do not circle hidden masses, but dance to laws of motion not yet written. Adding to the unease was the connection to dark energy. If dark matter is the sculptor of galaxies, dark energy is the expansionist, driving the cosmos apart at accelerating speed. Together they compose 95% of reality. Both remain invisible, unmeasurable, defined more by absence than presence. Are they two sides of a deeper phenomenon, linked in ways beyond current imagination? Some theorists whisper of unified fields, of cosmic symmetries broken at the dawn of time. Leaving only faint relics we misinterpret as separate forces. Each discovery seemed to add depth rather than resolution. The bullet cluster proved that. Dark matter behaved like a substance, yet small galaxies contradicted simulations. The cosmic web showed its guiding hand, yet black holes grew too fast. The Hubble constant tore at the seams of cosmology, hinting at hidden physics. With every attempt to pin it down, the mystery grew more defiant. Philosophical unease seeped into the silence of observatories. Humanity has always lived by what is visible, by the fire of stars, by the sun that rises, by the lights that guide, across seas. Yet the universe now appeared steered not by light, but by shadows. Most of existence is unseen, perhaps unknowable, and the visible world is only a faint trace. To walk through the cosmos is to step on a floor of ghosts. The escalation was not only scientific, but existential. If galaxies, stars, and even human bodies are scaffolded by what cannot be touched, then what does it mean to be real? If the lighthouse that steadies the universe is built on nothing visible, then perhaps the cosmos itself is more absence than presence, more hidden than revealed. With the mystery deepened, science turned not only to observation, but to imagination. For, if the lighthouse of the universe is built on an invisible foundation, what could that foundation be? Theories multiplied like constellations, each a glimmer of explanation, each carrying its own promise and doubt. The first and longest-standing contender is the idea of WIMPs, weakly interacting massive particles. Born from the mathematics of particle physics, WIMPs were envisioned as heavy cousins of known particles, massive enough to provide gravity's pull, but so aloof they rarely collided with ordinary matter. Their existence seemed natural within the framework of supersymmetry, a theory that proposed each known particle has a heavier twin. For decades, detectors buried deep in mines have waited for a single WIMP to strike a nucleus, releasing the faintest flash of light. Yet experiment after experiment has come up empty, leaving silence where once there was confidence. Another path pointed to the axion, a particle far lighter, almost ghostly. Axions were born not from cosmology, but from an attempt to resolve puzzles in quantum chromodynamics, the theory of the strong force. If they exist, they could stream invisibly through the cosmos, their collective presence providing the missing mass. Experiments now use magnetic fields and resonant cavities to try to coax them into revealing themselves as photons. The axion, if found, could solve two mysteries at once: the balance of quantum theory and the invisible skeleton of the universe. Others looked to the family of neutrinos, already infamous for their ghostly refusal to interact. The known neutrinos are too light to account for dark matter, but theorists proposed a hidden sibling, the sterile neutrino. Unlike the three neutrino types that weakly interact, This sterile form would ignore all forces except gravity. Telescopes have searched for its subtle signature, a faint glow from rare decays. Some hints have appeared, quickly contested, never yet conclusive. Beyond particles, some cast their gaze back to the earliest moments of time. Could dark matter be made not of particles at all, but of collapsed relics of the infant universe? Primordial black holes, forged from density fluctuations moments after the Big Bang, could drift through galaxies unseen. Unlike stellar black holes, they need not be massive. They could range from asteroid-sized to solar mass objects, scattered like hidden embers. Their gravity could mimic the effects of dark matter. Observations of microlensing events, starlight briefly magnified as unseen masses pass, test this idea. So far, primordial black holes remain only a possibility, their existence neither proven nor eliminated. Yet another school suggests that dark matter is not a thing at all, but a sign that human understanding of gravity is incomplete. Modified Newtonian dynamics. Mont proposed that gravity behaves differently at extremely low excitations, such as those governing galaxies. This could explain the flat rotation curves without invoking unseen mass. Variants like Teves attempted to extend this idea into relativity, but observations like the bullet cluster, where visible matter and gravitational pull separate, dealt blows to such theories. Still, the persistence of anomalies keeps modified gravity alive, haunting the edges of cosmology. More radical are ideas that dark matter is not a substance but an emergent effect. Theories of entropic gravity, pioneered by Eric Verland, suggest that gravity itself may not be fundamental but statistical, a byproduct of the universe's information content. In this view, the additional pull attributed to dark matter arises naturally from the way spacetime stores information. If true, dark matter is not matter at all but a mirage, an echo of entropy's mathematics. Still deeper speculation ties dark matter to the structure of reality itself. The holographic principle proposes that the three-dimensional universe may be a projection of information inscribed on a two-dimensional boundary. Dark matter could be a signal of this hidden encoding, a distortion born from the deeper geometry of space. And then there are whispers of multiverse theories. If reality consists of many universes, each with its own laws and contents, then perhaps what is felt as dark matter is leakage, gravity from neighboring dimensions tugging faintly on this cosmos. Some string theorists imagine hidden brains, parallel to our universe, their matter invisible yet gravitationally present. In such visions, the lighthouse is not alone on its ocean. Other lighthouses shine nearby, their beams reaching faintly across the void. Each theory carries not only physics, but philosophy. If WIMPs or Ixions exist, then the lighthouse is real, built on a foundation of unseen particles as solid as protons and neutrons. If primordial black holes are the answer, then dark matter is ancient memory, written in collapsed knots of the earliest cosmos. If modified gravity prevails, then the foundation is not absent but mistaken, the equations themselves asking to be rewritten. If emergent or holographic theories are right, then the lighthouse is not built on stone or air, but on information, the most abstract foundation of all. Speculation stretches further still. Could dark matter interact with itself, forming not only structure but complexity? Could there be dark chemistry, dark stars, even dark life, invisible neighbors drifting alongside the luminous cosmos, if the unseen matter composes most of reality? then perhaps the visible is the exception, not the rule. The lighthouse, so long thought to be built on nothing, may in truth stand atop an entire continent unseen. The paradox remains. Dark matter explains galaxies, clusters, and the cosmic web, yet eludes every trap set for it. Each hypothesis shines like a lantern, illuminating one corridor of possibility, only to leave others in shadow. The lighthouse stands, its beams sweeping across the abyss, but the foundation remains hidden. If the lighthouse of the universe is truly built on an unseen foundation, then science has mobilized an entire armada of instruments to search for the stones beneath the waves. Telescopes, detectors, accelerators, and simulations all serve as lanterns pointed into the abyss, each hoping to catch even a glimmer of the hidden architecture beneath mountains. Inside caverns, shielded from cosmic rays, lie vast chambers of liquid xenon. Zenit in Italy, Luxor-Zeppelin in South Dakota, and Pandex in China all wait in patient silence. Their purpose, to sense the faintest flash of light, the gentlest ripple of energy, should a WIMP pass through and collide with an atomic nucleus. Decades of waiting have yielded no definitive signal, yet the search continues with ever greater sensitivity. These experiments are humanity's wells dug into the dark, listening for whispers of particles that refuse to speak far above the Earth. Satellite observatories trace the gravitational maps of the cosmos. The Planck mission charted the cosmic microwave background with exquisite precision, revealing the ratios of normal matter, and dark energy. Now, new projects push forward. The Euclid spacecraft, launched by the European Space Agency, is mapping billions of galaxies to trace how invisible matter sculpts cosmic structure. On Earth, the Vera C. Rubin Observatory is preparing to survey the night sky in unprecedented detail, capturing the dance of galaxies and the subtle bending of light by unseen mass. These are cartographers of shadow, mapping a continent that cannot be seen. Gravity itself becomes a tool. Through gravitational lensing, scientists measure how light from distant galaxies bends around clusters. Sometimes the lens reveals far more mass than stars and gas can account for. The Bullet Cluster, a cosmic collision of galaxies, showed this. Separation clearly, visible matter lagging behind while gravity's pull raced ahead. This remains one of the clearest demonstrations that something unseen, something real, is there. Future surveys, like the Nancy Grace Roman Space Telescope, will use lensing across the sky, attempting to weave the full web of the dark scaffold. Meanwhile, particle accelerators, like the Large Hadron Collider, search for new physics. If supersymmetry exists, its partner particles might emerge in high-energy collisions. So far, none have appeared. Yet the Collider's experiments refine the boundaries of what dark matter could be, ruling out wide swaths of theory. Each null result is not failure, but guidance, a narrowing of paths through the labyrinth. Plans for future colliders, even larger than the LHC, carry the hope of pushing further still, probing energies where the invisible might finally step into view. Radio, astronomy brings another weapon to the search. Arrays such as LOFAR in Europe and the Future Square Kilometre Array in Australia and South Africa are turning their ears to the universe's faintest whispers. By mapping the 21-centimetre hydrogen line across cosmic time, these telescopes will trace how matter clustered during the Dark Ages and the cosmic dawn. Since dark matter shaped this clustering, these maps may reveal its fingerprints on the first stars. Long before galaxies fully formed, even gravitational wave astronomy enters. The hunt, Instruments like LIGO, Virgo, and Cagra listen to ripples in spacetime from colliding black holes and neutron stars. If primordial black holes make up dark matter, their mergers might be heard in this cosmic symphony. The planned LISA mission, a gravitational wave detector in space, will listen for even deeper signals, potentially tracing back to the earliest structures seeded by dark matter itself. Supercomputers provide another tool, building universes in silico. The Millennium Simulation, the Illustrious Project, and successors create digital cosmoses seeded with dark matter. These simulations show galaxies forming along vast filaments, a cosmic web shaped by invisible scaffolding. By comparing such models with observations, physicists test whether their unseen matter behaves as expected. Anomalies, like the distribution of dwarf galaxies or the density of galactic cores, challenge and refine the models. The computer becomes a lantern, illuminating how the hidden might flow. Even chemical archaeology plays its role. Astronomers study ancient stars in the halo of the Milky Way. These stars formed early, from gas touched only lightly by previous generations. Their chemical fingerprints may hold echoes of the first supernova explosions influenced by dark matter's gravity. By decoding these patterns, scientists glimpse the role of the invisible in shaping the earliest chapters of cosmic history. The arsenal grows, from mines to mountaintops, satellites to supercomputers, detectors to telescopes. The effort is unified to catch the invisible foundation of existence. Yet despite the enormity of this pursuit, the quarry remains elusive. Each tool reveals more of the structure, the pull, the consequences of dark matter, but never the thing itself. Still, the search presses on. For if dark matter is found, it will not merely complete a puzzle. It will rewrite the story of the cosmos, showing that most of reality has always been hidden. If it is not found, then the implications may be greater still, that gravity itself is misunderstood, that physics requires a revolution as profound as Einstein's. The lighthouse stands. Science builds ladders, telescopes, detectors, trying to touch the stones beneath it. Yet whether those stones are particles, black holes, emergent effects, or nothing at all, remains unanswered. The search continues, for in that answer lies the truth of what holds the universe together. The universe glows, yet its foundation is silent. Stars flare, galaxies spin, black holes devour. But all of this theater rests upon an invisible stage. Dark matter does not shimmer, it does not burn, it does not sing in electromagnetic waves, and yet, without it, there would be no stage at all. The lighthouse of existence would stand on nothing, its beams sweeping across an abyss without support. To reflect upon this is to confront fragility. If dark matter were to vanish, galaxies would unravel. Stars would drift apart like sparks scattered from a dying fire. Planets, set free from orbits, would wander into the dark. Existence itself, so seemingly stable, relies on something unseen, something humanity cannot touch, cannot weigh, cannot hold. We walk upon a floor of shadows, trusting it to bear our weight. Philosophers once argued that reality was what could be seen, heard, touched. Science overturned that certainty. It revealed atoms, quarks, and neutrinos, invisible realms beneath perception. But dark matter is stranger still. It does not simply hide, it refuses interaction. It is the sculptor that leaves no trace of the sculpting. The universe we know, every star, every world, every human life is but a faint embroidery stitched on its invisible loom. This realization unsettles the human story. For millennia, humanity gazed upward, believing the heavens were filled with fire, with divine order, with light. Now it is known that light itself is the minority, the exception, the surface of something vaster. The true universe is shadow. More than 4/5 of existence is invisible. Dark matter and dark energy together. The cosmos humanity inhabits is not the cosmos it perceives. Yet in this darkness lies a paradox of wonder. For though unseen, the lighthouse holds steady. The stars rise each night. Galaxies bind together. The cosmic web stretches across billions. Of light years the invisible is faithful. It does not falter. It does not waver. The unseen architecture is the reason that light itself endures. There is also an echo here, a metaphor woven into human existence. Just as galaxies are bound by what they cannot see, so too are lives bound by forces unseen. Memory, love, time, mortality. Humanity builds its own lighthouses upon mystery's trust, meaning, belief. Foundations as intangible as dark matter, yet just as indispensable. The cosmos mirrors the human condition, both luminous on the surface, both sustained by what resists comprehension. Science reaches toward this truth with instruments, with theories, with dreams of particles and fields. But perhaps the deeper lesson lies not in what is found, but in what remains hidden. To accept that most of reality is unseen is to accept humility. It is to recognize that human knowledge, however vast, floats atop an ocean whose depths remain untouched. Will dark matter one day be revealed as a particle colliding faintly in a detector's heart? Will it emerge as a shadow world with its own forces and galaxies invisible to ours? Or will it dissolve entirely, replaced by a new vision of gravity, of spacetime, of reality itself? Each possibility expands the horizon of wonder. Until then, the stars shine, galaxies turn, worlds endure, all because of something unseen, silent, steadfast. The lighthouse built on nothing guides all of existence. Though its foundation has never been found, the closing image is haunting yet serene, the cosmos sweeping outward, galaxies strung upon filaments of shadow. Humanity sails within this cathedral of darkness, illuminated by points of light, unaware that beneath every orbit and every sunrise lies an invisible hand. The universe endures not because of what is seen, but because of what is hidden, and so the final reflection lingers. The greatest truth may not lie in light, but in shadow. The cosmos is a lighthouse built on nothing, and yet it holds.